property do we have? We talked about the carbonates. Let's talk about their nitrates. The same thing happens to their nitrates. Now, let me throw this question to you. What do you expect to experience? What do you expect to experience when you decompose the nitrate of a group 1 salt and the nitrate of a group 2 salt? Because group 1 atoms or elements are more reactive than group 2, right? It means that they would hold on, there is a stronger bond between these atoms and the other elements making up the compound. It means that they can hold on to their elements more than group 2, right? So what does that mean? When you decompose the triazonitrate 5 salts of group 2, the triazonitrate 5 salts decompose. They are also thermolabile. So they decompose upon heating to give the oxide of the metal, nitrogen 4 oxide gas, and give off oxygen gas. Now, please give off oxygen gas. Please take note that the equations are far easier than these notes present, right? The notes to me look more cumbersome compared to the equation. And give off oxygen. Give off oxygen gas. So let's back that up with an equation. If we decompose the triazonitrate 5 salt of magnesium to, right, solid. Now, we explained how you have, why is it MgNO3 2 and not, why is it this compound and not this compound, right? Now, we explained all these, I think, in one of our lectures on acid, base, and salt. But now let's cheat that in here so you would understand when to put 2 as a subscript in brackets, or 3, or you don't put any subscript or whatever. Now, you know, magnesium is a group 2 element, which means in solution, right, you have, okay, let's just put it here. In solution, it ionizes to give its dipositively charged ion. What about NO3? Nitrogen, we've not gotten there, but nitrogen is a group 5 element, which means that it can give off 5 valence electrons or get 3 electrons. Now let's assume, just an assumption, that it gives us 5 valence electrons. It means it becomes 5 plus, right? And then what about oxygen? Oxygen belongs to group 6 of the periodic table. It can either give off 6 of its electrons or get 2 electrons. Now, let's assume it gets 2. Now, this is the first element in the radical. This is NO3. The first element should be a cation, and the next should be an anion. So how can nitrogen be a cation? By donating all of its 5 valence electrons, and then that's how you have 5 plus. How can oxygen be an anion? By gaining 2 electrons, and that's why you have it as that anion. But you see that oxygen there, we have 3 atoms of it. So it means you have O2 3 times, right? So when you do plus 5, minus what? Minus 6. How do we have minus 6? Because we have 2 minus in 3 places. It means you have a net charge of minus 1. So the radical is NO3 minus. That is the net charge you have. And then when you do your valence crossing, you have 1 times magnesium. That is magnesium. 2 times NO3. That is NO3 2. And that's how you get the compounds of any, that's how you get any compound you wish. Okay? The rule applies to all compounds in chemistry, with a few exceptions. And the exceptions are in the case of large atoms like the members of the noble gases, lower members of the noble gases like radon, like xenon, like krypton. All right? They're very large. And then there is a concept called expanded octets, all right, which allows us waive off the rules in their case. But we won't talk about that in this lecture. It's not a new level concept. Okay, but for the rest of the compounds, you can get that way. Okay, let's see. Now, what happens to their nitrate? We said when the nitrates decompose, they give up the oxide of the metal. What is oxide of this metal? Magnesium oxide, solid, right? What else do you have? They give up nitrogen 4 oxide gas. Nitrogen 4 oxide gas. What else do you have? They give up oxygen gas. Oxygen gas. That's what the rule tells us. And then these are gases. These are gases. You know nitrogen 4 oxide gas is giving off when you see brown fumes. All right, brown gases. Then you know it's NO2. And then you won't know oxygen is giving off except to test for it chemically. All right. One way to test for it, a rekindle is a glowing splinter. So when you light a match, all right, in an oxygen-saturated environment, you see it rekindles. The splinter rekindles, it goes off, then comes back on, like your matches. Very fast, it goes off, then comes on. That's what you call a rekindle. So a rekindle is a glowing splinter, and that's what you have. Let's say is our equation balanced. You have 2 of this, okay? So 1 magnesium atom, 6 oxygen atoms. Okay, this is, we give up nitrogen 2 oxide. That was a boo-boo. We give up nitrogen 2 oxide, not 4, 2. So that's nitrogen 2 oxide, NO gas, and oxygen, okay? So now you can see this is balanced. You have 6 oxygen atoms, right? You have 2 as 4, 6, yeah. MgNO3, magnesium 1, 1, nitrogen 2, 2, yes. Oxygen 6. Oxygen is 1 plus 2, 3. How do we make this 3? By alphing it. So this is 3 over 2, right? And then this is 2 MgNO3 2 to give us 2 MgO plus 4 NO gas plus 3 O2. And that's what you have. Okay, so when you decompose the triazonitrate 5 salts of group 2, you expect to have the oxide, nitrogen 4 oxide, and oxygen gas. So can you give me the product of the decomposition of calcium nitrate? Calcium nitrate. The same rule applies, right? Now, it will have the same stoichiometric coefficient. Here you have calcium oxide, you have nitrogen 4 oxide gas, you have oxygen gas. And that's the rule. All right. So guys, that's it about group 2 elements. We said number 1, they are alkali earth metals because they react with water just like group 1 to produce alkali and liberate hydrogen gas. But the fact that they are found in large amounts of the earth crust allows for the name earth. So they are alkaline earth metals, right? They have 2 valence electrons. That's why they are put to group 2 of the periodic table. You can as well call them the beryllium family because beryllium is the first member of that group. Other members are magnesium, calcium, strontium, radium, strontium, radium, and barium, right? And then, of course, they are ionized by loss of 2 electrons to form a dipositively charged ion. We talked about their carbonate salts and the nitrate salts. Both of them are thermolabile. The carbonate salts decompose in the presence of heat to produce the oxide of the metal and give off carbon 4 oxide gas, while the nitrate salts decompose in the presence of heat to produce the oxide of the metal, nitrogen 2 oxide, and liberate carbon 4 oxide. And that's it about group 2 elements. Please, it is important to note that not all group 2 salts are water soluble. In fact, most of them are insoluble in water, right? Unlike group 1, where they have all their salts to be soluble in water. And of course, they are better reducing agents than group 3, but less as good as group 1. So guys, that's it about group 2 elements. Thank you for sticking with us, and we hope that you understand what group 2 elements are, and you can give their chemical properties. Guys, do want to join us in the next lecture when we talk about group 3 elements. Thanks for sticking with us, and we shall see you in the next lecture.